Welcome to the series called What the Hell is Organic Chemistry? Also known as Why Did I Choose This Major? This is a series where I help people who are struggling with chemistry, or people who are just curious about what the hell chemistry is really. My name is Zeanium, and today we're diving into what the hell are bond line drawings. Why do chemists draw molecules like they're censoring half the atoms? Why is carbon apparently shy and refuses to show up? And who the hell decided that zigzag lines were an acceptable way to communicate information? Seriously, how are you supposed to read these without losing your sanity? Blink once and it's ethanol, blink twice, it's suddenly a felony. By the end of this video, those weird zigzag drawings will actually make sense. I promise. To do well in organic chemistry, we must first learn to read the drawings that organic chemists use. These are not doodles. These aren't Picasso art pieces. These are actually molecules, even if they look like they were sketched during a caffeine overdose, but those are actual molecules. So when you look at a molecule, it's absolutely critical that you understand everything hidden in those innocent looking lines and angles, like which atoms are actually there, how they're connected, and which atoms are being intentionally ghosted like a bad Tinder date. Why is this so important, you may ask? Because reactions, mechanisms, and predictions are all based on these drawings. This is basically the language of organic chemistry. So if you can't read them, organic chemistry quickly turns into chaos. Reaction stops making sense, mechanism looks straight up cursed, and even the easy stuff feels more like impossible than Mission Impossible. Except Tom Cruise isn't here to save you. But don't worry, we're about to fix that. So, the same molecule can be drawn in multiple different ways. Different styles, same molecule, same chemistry. And it's not like the molecule didn't evolve or anything, so nothing has changed except the style of the drawing. So, as you can see below, it's 3 different drawings, but it's the same exact molecules. So it has same atoms, same bonds, and same chemical behavior. So, we like to call this one right here, we like to call this Lewis structure. Lewis structure. This is called a Lewis structure. This, on the other hand, is called a condensed structure. Condensed Lewis structure. And this is what we call a bond line drawing. This is a bond line drawing, this is a condensed Lewis structure, and this is a Lewis structure. So we have 3 ways to draw a molecule in organic chemistry. How to read bond line drawings. Bond line drawings focus on the carbon skeleton of a molecule. You can think of it as like the molecule's spine. Everything else is just accessories. So that means that how the carbon atoms are connected, which atoms are attached to that spine, like OH or Br as a functional group, which I will explain in a later video what functional groups are. So you may be asking, why carbon and not the other elements like nitrogen and oxygen and maybe cobalt? Because in organic chemistry, carbon is the main character. So if you know where the carbons are, you already understand most of the molecule. Everything else is just vibing around them. Now about those lines, they are drawn in a zigzag pattern. And here's the most important rule in all of bond line drawings. So, each corner or endpoint represent a carbon atom. Yes, even the ones with no label. Especially with the ones with no label. So if you see a corner, boom, carbon. Line ends, carbon. So we have some examples here. We have some molecules right here. So how many carbon atoms do you think there is in this molecule? We can count it by the zigzag, like the corner, where the corner is, right here. So this is a C, this is a carbon, 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 and this is a carbon. And there is 1, 2, 3, 4, 5, 6, 7. There's 7 carbon atoms in this molecule. 7C, just 7C carbon carbons. Here we have the same principle. How many carbon atoms are there? Every corner and every line ending is a carbon atom. So we say 1, 2, 3, 4, 5, 6. There's 6 carbon atoms. 6 carbon. Yep. And this one, we do the same principle. 1, 2, 3, 4. There's then 4 carbons. Yes. So this is how you can read a bond line drawing. And so you may be wondering, like, what about the hydrogens on the carbon? They're still there, but they just are invisible. And why hide them? Well, if we like did a drawing of a whole molecule with every hydrogen that we draw, I can show you right here. So we have a bond line structure of penicillin G. It's medicine that helps to fight bacteria. So this is a bond line structure of penicillin G, and here you can see that there is no hydrogen, only on the alcohol, the OH group, and the amine group, and they're on like visible in inner. Now let me show you what horror you will witness if we drew every hydrogen. Yep, as you can see, drawing every hydrogen will turn molecules into hairy nightmares. It will be slow, messy, and borderline unreadable. And chemists value their sanity, sometimes. So instead, hydrogens are not drawn, but they're there. Carbon always have 4 bonds. Our job is to mentally fill in the missing ones. For example, the compound below, like this one, the 7 one that we just did. Let me draw hydrogen as blue. Yes, the compound contains 7 carbon atoms, yes, that we know. And if we want to like draw the hydrogens, there is 1, 2, 3 on this. There is 1. There is 2. There's 2. There's 2. There's 2. There's 2. There's 2. There's 2. And there's. It takes a lot of like work to draw all the damn hydrogen. So we just don't do that with all the carbons, or else it will take forever. So double bonds are shown with 2 lines. As you can see here, this one. This is a double bond. And triple bonds are shown in 3 lines. This is a triple bond. Okay, so now important rule with triple bonds. When drawing triple bonds, always draw them in a straight line. No zigzag, like the other. Why? Because triple bonds are linear. I'll explain why in another video, so stay tuned for that. Here is where organic chemistry tries to mess with you. So straight lines can make it harder to count carbons because you lose the nice corner rhythm, right? And yeah, so this right here, this makes it hard to count the carbon. So chemists sometimes leave a small gap on either side of the triple bond to help your eyes breathe. So this, what I'm talking about right here, this small gap right here. Yes, so both styles, when drawing triple bonds, both styles are correct, but this is more pleasing to look at. So like let me count the carbon here. So 1, 2, 3, 4, 5, 6. So it will be like 1, 2, 3, 4, 5, 6. So yeah, both styles are correct. Gap or no gap, same molecule, same chemistry, same emotional damage, all that. And so don't let triple bonds scare you. They're not like dangerous, they're just dramatic. So once you see a straight line, your brain should just instantly say, okay, triple bond, I'm fine. Now that we got that over, let's do some exercises. Count the numbers of carbon atoms in each of the following drawings. That's pretty easy. So if you like pause the video right now and try to do the exercise and see if you're correct. You probably pause the video, I don't know. So let me do the first one. So just follow the same principle. Every corner, every end is a carbon atom. 1, 2, 3, 4, 5, 6. 6 carbon atoms. Here, 1, 2, 3, 4, 5. 5 carbon atoms. 1, 2, 3, 4, 5, 6. 6 carbon atoms. 1, 2, 3, 4, 5. 5 carbon atoms. 1, 2, 3, 4. 4 carbon atoms. What the hell is this, you may be asking? Well, in a future video, you will probably understand what the hell this is. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon atoms. Did I write? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 carbon atoms in total. Yes, so this is basically the exercise. Just have to count the carbon atoms. So yeah, that was that. All right, so now that we probably mastered counting carbons without crying, it's time for the next challenge: counting hydrogen's atoms. And there's one rule you must remember: hydrogen atoms attached to atoms other than carbon must be drawn. So I'm talking about this atom, nitrogen, an alcohol, and a thiol. So hydrogen's atom attached to atoms other than carbon must be drawn. So we have hydrogens on oxygen and nitrogen. They're always visible. Don't hide them, because those hydrogens affect the reactivity, acidity, and bonding in important ways. We can't afford to hide them. So hydrogens attached to carbon are not drawn. Invisible, but very much mandatory, like taxes. So how do we know how many hydrogens a carbon has if a chemist refuses to draw them? Like, some chemists are lazy. So the golden rule: engrave this into your soul. An uncharged carbon atom. Sorry, I have like a dry throat right now. Oh, an uncharged carbon atom always has 4 bonds. Always, not usually, not unless it's tired, always. You may be wondering, why 4? Why not 5, 6, 7?
Shut the fuck up.
Why only 4? Because carbon has 4 orbitals, and it wants all of them occupied. I'll get in another video about orbitals and what they are. So in the drawing below, the highlighted carbon is showing 2 bonds. Right here. So let us draw the hydrogens. And so this right here has 2. So we can calculate it by like this. So it has 1, 2, and then we have to count until it hits 4. 3, 4. So 2 hydrogens it has. So this has 2 hydrogens. We can do it with the other one. This is a carbon. How many bonds it has? 1, 2. Count until 4. 3, 4. Also 2. Together, and then the same principle here. When it, at the end, we can say like a carbon is here, so it has 1, and then we have to add on until we hit 4. So 2, 3, 4. It has 3 hydrogens. So we're gonna draw it with 3 hydrogens. That's basically it, how you can draw hydrogens and how to calculate the hydrogens. So yeah, carbon doesn't like being incomplete, so we automatically assume it has 2 hydrogens to reach 4 total bonds. That's why we don't draw hydrogens on carbon. We can reconstruct them mentally. And the simple method, like I said before, count the bonds you see on carbon, add hydrogens until the total is 4. That's pretty much it. So at first you will need to count carefully, and after some time and practice, you won't even think about it. You just start seeing hydrogens instantly, even though they're undrawn. That's basically the goal. So let's practice. The following molecule has 9 bonds. Count the number hydrogen atoms connected to each carbon atom. So if you start here, this carbon atom, let me draw everything. So like the carbon also, carbon. And yeah, so we have a carbon here. We just add, it only has 1 bond, right? So 1, 2, 3, 4. So it has 3 hydrogens. So we add 3 hydrogens. There we go. And here we have another carbon. How many bonds it has? It has 2 bonds. Let me 1, 2. And how many bonds does this C have? This bond has 4 bonds. So that means that no hydrogen is available. So 1, 2, 3, 4. This carbon is occupied a lot. This carbon is also occupied, so it doesn't have any hydrogens. This carbon also is occupied since it has 1, 2, 3, 4 bonds, so it doesn't have any hydrogens. This carbon is 1, 2, 3, 4. Doesn't always doesn't have hydrogens. And then the carbon over here, it has 1 bond, 2, 3, 4, 3 hydrogens. So let me draw that. And the carbon here, it has where's my laser pointer? 1, 2, 3. 3 bonds. That means it has 1 hydrogen. And then it's a singular bond again, which means it has 3 hydrogens. Color. There we go. So yeah, that's the exercise done and dusted. For each of the following molecules, count the number of hydrogen atoms connected to each carbon atom. We just do the same principle we just did. First one, this is a C. How many carbon atoms does it have? No, sorry, hydrogen. 1, 2, 3, 4. It's occupied, so it doesn't have any. This one, it has 1, 2, 3. That means it has 1 carbon atom. Not carbon, hydrogen. Okay, and this also has 1 hydrogen atom. And this one, it has 1, 2, 3, 4, 2 hydrogen atoms. And this one has 2. And this one also has 2. Yep, that was that. Now be wondering what the hell is that compound? Well, yes, it's a compound. It can also be drawn. So we just do the same principle as we just did. Carbon, 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 and carbon. And hydrogens, we say how many bonds does this carbon have of hydrogen? It has 1, 2, 3, 4. It only has 1. So it's like this. How many does the other one have? 1, 2, 3, 4. It's occupied, so it doesn't have any. This one, 1, 2, 3. It has 1 hydrogen atom. This one right here, it has 1, 2, 3, 4. It has 2 hydrogen atoms. This one, 1, 2, 3, 4. 4 hydrogen atoms. Oh, sorry, 2 hydrogen atoms. And yeah, that's pretty much it of this one. This one, easy again. Count the carbons first. 1, 2, 3. And we count the hydrogen. How many bonds does it have? 1, 2, 3, 4. 3 bonds. So 1, 2, 3. And what's your guess on this one? That's right, there's no hydrogen available for that compound since it already has 4 orbitals. What about this one? Yeah, that's right. It has 3 hydrogens. And yeah, that's pretty much the one. Alright, so how to draw bond line drawings. Now that we know how to read bond line drawings, it's time to learn how to draw them. Let's take following molecule as our our example. To draw it as a bond line drawing, we focus on one thing and one thing only, the carbon skeleton. That means we do not draw carbon, we do not draw hydrogen, but we must draw the all other atoms, if there are other atoms. So using this rule, the example molecule simplifies to this. So let's draw this as a bond line drawing. So it has 1, 2, it has 1, 2, 3, 4, 5 carbons. All right, and it has oxygen in it. So we're gonna do this. So it has 1, 2, 3, 4. And then an oxygen right here. So it's gonna be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, that's right. And on the 5, we draw like a methyl group. Dimethyl groups. You can either draw it like this, or you can draw it like this. It's the same. And yeah, that's basically it. That's the molecule. I'm not kidding. That's how easy it is to draw the molecule as a bond line drawing instead of a Lewis structure. So yeah, that's the simplified version of the Lewis structure. Alright, so helpful drawing tips. Straight carbon chains are drawn in a zigzag, so this is better because it represents its 3D shape. So as you can see here, this compound right here is drawn as like this. What the hell is going on with my laser? This is drawn like this. So when drawing double bonds, draw other bonds as far away as possible. This keeps the drawings clean and readable. So this is much better than this. Keep them clean. This molecule just looks like it's sad. And when drawing zigzags, it does not matter in which direction you start drawing. So left, right, up, down, they're all correct. So this is correct, this is one, and this one is correct. So it doesn't matter when drawing zigzags. All right. So let's do another task. Draw a bond line drawing in the box provided. You can pause the video if you want to try it yourself. Like, give it a shot. I recommend it. And come back to the video after you're done. All right, so we count the carbon atoms. So 1, 2, 3, 4 carbon atoms and oxygen in the middle. So we say 1, 2, 3, 4 oxygen. So 1, 2, 3, 4, boom, that's right. And there's a dimethyl group right here, methyls. It's gonna be like the previous one we just did, just this one. And yeah, that's about it. That's basically it. That's the bond line drawing right there. So pretty simple. Okay, mistakes to avoid. Number 1, giving carbon too many bonds. So never draw a carbon atom with more than 4 bonds. Carbon gets 4 bonds only. This is not a suggestion. This is some Thanos level rule, perfectly balanced as all things should be. So 5 bonds on carbon, that's like releasing a movie before the CGI is finished. Like it's, no, absolutely not. And a 5th bond doesn't just break chemistry, 5th bond breaks chemistry and reality. And this applies to all second row elements. So don't do that. Don't draw carbon atom with more than 4 bonds. Then you already know something is wrong. Number 2, mixing drawing styles. You must pick one style. Draw all carbon atoms, or like draw all carbons and all hydrogens, or draw a bond-like structure with neither. You cannot draw carbons but hide hydrogens. Like this one. What the hell is this? No. That drawing is incomplete and incorrect. And that's so illegal, it's like wearing socks on sandals. Like, don't do that. If your TA saw that on your assignment, they will literally kick you out of the lecture. Don't do that. So yeah, draw all carbons and all hydrogens, or draw a bond-like structure with neither. And I'll suggest the bond-line structure than the lever structure, because the lever structure takes a lot of time. So best option is bond-line drawings. Okay, number 3, crowding your bonds. Spread your bonds out as much as possible. What I mean by is that more space means easier reading, easier counting, fewer mistakes, and don't draw molecules like they're fighting for the Wi-Fi password. Honestly, like, don't draw them like so crowded. Like, draw them like this, and not like this. It looks like it has a broken angle or something. Is there anything else I want to add? No. So yeah, that was just a simple introduction to chemistry, bond-line drawings. So how to read bond-line drawings. So if this helped you, leave a like and also write in the comments. Like if you want me to explain a topic or have some other suggestions, I'll be happy to help. Or just say hi. Just say anything. And yeah, until next time, eat well, stay hydrated.